Hey, Advanced Geometry, welcome back. This is part 2 of the 2.6 notes. Part 2 of the 2.6 notes. This is part 2 of the 2.6 notes. I know this is kind of a long section, so I apologize for that, but it's important we spend some time on this. This is a pretty big concept in the class, so here we go. So we're just going to continue talking about these special angle relationships, and before we begin doing some examples, I just want to tell you that sometimes these types of angles aren't so obvious. So let me show you what I mean by that. Let me just get a fresh sheet of paper here. And I'm just going to draw a little sketch of, let's start with corresponding angles, okay? So here we go, corresponding angles. And I'm going to draw it a little bit differently. So check out the parallel lines here. Here's one, and I know my lines are terrible. There's another one, not super straight, but you'll understand here in just a minute. And here's my transversal. All right, so you guys, angle 1 and angle 2 are corresponding angles, and if these lines are parallel, then they are congruent to each other. Now, it's pretty obvious to see that when you can see both lines in their entirety and you can see the transversal. But what happens sometimes is you end up with a diagram that maybe looks like this. Maybe this part of the line is not in the diagram, and this part of the line is not in the diagram, and maybe the transversal doesn't continue on, and neither does, this part of the line, and so maybe it looks more like this. All right, so you could have a diagram like this, and if I tell you that these segments here are parallel to one another, you would still be able to deduce that angles 1 and 2 are congruent because they're corresponding angles. All right, so the idea is you got to get past like the big picture that has the full lines and full transversal and be able to identify these things under different circumstances. And so maybe right now you can even see what I'm going for is the way I remember corresponding angles is I look for what are called windshield wipers. Can you see that in my little picture here? Here's the front of the car. All right, here's the lights, here's the tires, car going back. Yeah, I'm not a good artist, but you get the point. Here's the back tire. Booyah! Look at that, beautiful car. So here are my windshield wipers. That's what I'm looking for when I see corresponding angles. So I'll try to point that out as we do some examples. That is a terrible car. All right. Another one is when you're looking at alternate interior angles. This is really easy to see when you really focus on this. Interior angles. Check it out. For alternate interior angles, what I'm looking for are Z's. Okay? Here are, and if these lines are parallel, this angle and this angle are alternate interior angles, and check it out. Bam, bam, bam. Whenever you see a Z, the little angles formed are alternate interior angles. And then the last little look for is for same side interior angles. So here are my same side interior angles here. Okay, if these lines are parallel, then my same side interior angles, this angle and this angle are supplementary. So maybe that's 100 degrees. I know this is 80. Now suppose all this stuff is gone. You can still find those same side interior angles, because my little stupid drawing here looks to me like a broken ruler. All right, so I call this the broken ruler when I'm looking for same side interior angles. You guys, these are stupid ways to remember and to look for things. So as we do these examples, I'm going to point that out to you. So let's take a look at these examples. And these are same side interior angles. All right, here we go. Let's do some examples. Maybe. Here we go. So first examples are going to be really easy. Okay, this will be like the first question on your assessment that I'm going to give you on this stuff. So check it out. I got two parallel lines cut by a transversal, and what's given to me is this angle is 50 degrees. All right, well, let's find the other ones. And what we're going to do is we're just going to talk about the relationship. So check it out. First, this angle and this angle are corresponding angles. And if parallel lines are cut by a transversal, corresponding angles are congruent. And congruent means they have the same measure. So x would be 50 degrees. All right. Next, this angle and this angle, if you look at the Z I just told you to look for, these are same side interior angle, or excuse me, alternate interior angles. And when parallel lines are cut by a transversal, alternate interior angles are also congruent. So y would be 50. And then the last one here is to find Z. And what's the special relationship between the given angle and Z? Well, check out my little broken ruler here. All right? These are same side interior angles, and same side interior angles are supplementary. So if this angle's 50, then Z has to be 130 degrees because same side interior angles are supplementary. All right? So the angles, you guys, they're either going to be congruent or supplementary. So sometimes you could even just look and be like, all right, well, this one that looks acute is 50, then this one that looks obtuse has to be 130. All right? It's almost as easy as that. All right, so in this case, I've kind of flipped around the diagram slightly, and we're just going to take a look and be like, okay, what's the relationship here? Well, the first relationship that I see is I see this angle that's given 103, and this angle B. You guys, they are alternate exterior angles. They're on alternate sides of the transversal, and they're in the exterior of the parallel lines. And when parallel lines are cut by a transversal, alternate exterior angles are congruent. Now, so if this is 103, then I can use the linear pair postulate and say, okay, well, if that's 103, then this has to be 77 degrees because the linear pair postulate says that the angles have to add to 180 degrees. So A would be 77. All right? All right, let's look at some harder examples. We really got to focus on finding those relationships. All right, so here, I've gotten rid of the ends of the lines, kind of cut off the transversal a little bit. So what we're really going to focus on here, you guys, is windshield wipers, the broken ruler, or the Z. So the first thing I notice are windshield wipers. Check this out. Here's like the bottom of the windshield. Here's one wiper. Here's the other wiper. Those lines are parallel. So X and 70, those are corresponding angles. So X would equal 70. And I don't need to put the degree mark because when I substitute 70 in for X, it's already X degrees. All right, so keep that in mind. All right, so we found X was 70. Let me erase all this stuff, and then we'll focus on finding some other stuff. So this was 70. All right, and you guys, what I do is I just fill in everything I know, and maybe it's not one of the variables, but I'll get to those variables eventually. So for instance, here's what I mean. If this angle's 50, notice this X. Well, that means this would be 50 degrees as well because they're vertical angles. And now, check out these three angles make a straight line. And if those three angles make a straight line, they've got to add to 180. So 70 and 50 is 120, which leaves 60 degrees left for Y. There you go. All right. So it's not all about quickly identifying alternate tier angles or corresponding angles. Sometimes you got to just start filling in angles, and what you're looking for will come to you. All right, look at this huge diagram. We got a lot going on here. So what I like to do is just kind of start with what's given. So I got 60 and I got 40 here. I'm going to start with what's given, and I'm just going to work my way around this diagram and see what I can figure out. So let's see. The first thing that I notice is corresponding angles. So here's what I mean. I've got these two parallel lines. So this line and this line, and I have this transversal. Well, at this intersection, the bottom left angle is 40. So at this intersection, the bottom left angle needs to be 40. And now these three angles, this one, and this one, all make a straight line. So 40 and 60 is 100, which leaves 80 degrees for Z. All right, and then let's figure out Y. Check out this. All right, let me erase all of my highlighting and make you see what Y is real quick. And having a highlighter might help you when you print stuff out. So let's go ahead and fill in what I already knew. So I already knew that this was 40 degrees, and I knew that this was 80 degrees. All right, now check out that this line and this line are parallel to each other. So scope this little sideways Z. So if this is 40 degrees, then this has to be 40 degrees because they're alternate interior angles. There we go. All right, so perfect. Let me erase all that, and I'll just keep the angle measures there. So again, this was 40. This was 40 as well. This was 80. All right, great. So, and then the last thing I noticed, you guys, is this Z to solve for X. Oops, froze a little bit. To solve for X, check this one out. There's another little Z. So 40 is equal to 2x plus 10. So I can subtract 10 from both sides and get 30 is equal to 2x. So x would be 15. So there we have it. By using alternate interior angles and corresponding angles and all that fun stuff, I was able to figure out x, y, and z. Now, one thing I'd like to point out, you guys, is just I didn't really use same side interior angles here, but let me show you how that would come into play. If this was 40 degrees, look at this. Here's my little broken ruler situation. So that means these two are same side interior angles, which makes them supplementary, makes them add to 180 degrees. So that angle would be 140. All right, and the last example here is kind of the hardest one. And so you see this diagram, we have some parallel lines. And so you guys, you got to really look for those look-fors, and here they are. Check it out. I have two broken ruler situations. I have this one, and I have this one. And so when I say broken ruler, I'm talking about same side interior angles. And when you have parallel lines that are cut by transversals and they have same side interior angles, are supplementary. And supplementary means they add to 180 degrees. So here's what I know. I know that 40 plus 2x plus y has to equal 180 degrees. And I know from this pair of same side interior angles that 3x plus y, or excuse me, 3x minus y, rather. Well, that sucked. Let me try that again. 3x minus y plus 60 also have to add to 180. These are also same side interior angles. So I have two variables. I have two equations. This is a system of equations. So I will simplify them, get them in standard form, and then I'm going to solve. So I'm going to subtract 40 from both sides to get 2x plus y is equal to 140 here. In this one, I will subtract 60 from both sides and get 3x minus y equals 120. Now I have a system of equations. Here we go. I got 2x plus y equals 140. And I got 3x minus y equals 120. Now check this out, you guys. I made this easy for you on purpose. They already eliminate. The y's already do. So I'm just going to add these together, and I get 5x is equal to 260 degrees. All right, and when I divide 260 by 5, I get, what do I get, 52? Let me just confirm that, okay? My mental math's not as strong as it used to be because it's first thing in the morning. But 52, perfect. I still got it. All right, so x is 52, and then to find y, I'm just going to choose an equation, maybe this one, and we'll just plug in. Instead of x, I have 52, and I'm going to solve for y. So 3 times 52 is at 156, minus y is equal to 120. And 120 minus 156 gives me, what, negative 36? So negative y is equal to negative 36. So that means y will be 36. Perfecto. And then you guys, it's always helpful to go back in and plug in and make sure you did it correctly. So I got x is 52 and y is 36, and let's just make sure that works. All right, so like for this angle, all right? 2 times x, so 2 times 52 is 104, and 104 plus 36 is 140. Hey, look, when I plug that in, these are supplementary. That's great, it worked. Let's check this one. 3 times 52 is 156, and 156 minus 36 is 120. And so these two are supplementary, so it must have done everything correctly. So be very careful to look for those relationships, and then you're going to have to use systems of equations and even quadratics still to solve these problems. All right, so I know that was a lot of information, and the video probably won't be quite as informative as if you're coming to the live lecture in class where we can kind of go through all this together. So, all right, have a good one.